It's 5.4 journal time. Equilateral and isosceles triangles, or they should say equilateral and equiangular, because if it's equilateral, it's also equiangular. Okay, let's rumble. Page 140 in your journal. This starts on. So this stuff is color-coded up here. First off, all these terms are for isosceles triangles only, not equilateral. Legs are our congruent sides, right there and right there. So this is a leg, because they are the ones that are marked congruent in the isosceles triangle. The vertex angle, it's the included angle between the two triangles, or between the two legs. That's this angle right here. You can see here's one leg, there's our other leg. They meet at the vertex angle, or the vertex of the vertex angle. So the base is the third side. It's not a leg. So we're talking this down here. It's not always the bottom. Notice in this one, our base is the side, or the left side of that there. So it doesn't have to be the bottom. It's just the third side. It's the one that's not one of the two congruent legs. Your base angles, these are opposite your legs. I've got these little blue lines up here that were it. So when we say opposite, yeah, if I go straight across, I'm running into this. That was drawn really weird there for me. But, you know, we're going to just bend it over to this angle a little bit. You know it's not this angle, because I'd have to just be going down this leg. That's not opposite. That's just going down the leg. I know it's not this angle, because I would just be going down this leg right here. Okay. I think I like that brighter blue. I think I'm just going to go to that. I think I'm going to keep that one. I think I like that better. So that opposite's a good skill. So I got this leg over here. And, you know, maybe not start in the center, but I can just go over this from right over there, and I run into that. That would be the opposite, the leg. That's the base angle over there. So a little too much got rid of there. Okay. Better diagrams in your book. I should have had this marked down on the pages before. Take a look on page 252 in your book. That's much, much better. Look at your book. There's always more information in there, better pictures and stuff too. And I want to get rid of this other. Okay, now we got a bunch of rules for these. If two sides of a triangle are congruent, those would be our legs again. So that's the leg. That's the leg they're talking about right there. So if two sides of a triangle are congruent, which are our legs, the angles opposite them are congruent. Now, I've got a whole bunch of stuff written out on opposite over here. So I'm going to look at this side first. My pen's not drawing really well. I think this needs to restart. So I've got side AC. The non-adjacent angle. Angle A is adjacent to that side. Angle C is adjacent to that side. That makes B the opposite angle. So that's going to be congruent. Again, that's where they're getting the idea of opposite. You're kind of going across from it over there. And that's got to be congruent. This side to that angle. See, that's opposite it over there. That makes those congruent. Always show these marks. Get your congruent marks on there. Mark the diagrams congruent. You're not going to see this stuff on there. That's what you're going to see. The other things are just there to help you see that that's the end mark that should be on there that we want to see. I also mentioned too, when you look at this one, if you look at it, AB, that's opposite C. So notice C's not the letter in there. That's what I'm saying here. The vertex of the opposite angle is the third letter of the triangle. So an example, AB. You got the other one here. You got AC. That's going to B. So B is the angle that's opposite. Here's side. We did this one in red before. There's side AC. Opposite is B. That's that third angle of the triangle idea. Converse of the base angle theorem. Notice this is just this theorem turned around. So that's what a converse is, if you recall. If angle B is congruent to angle C, then then segment AB is congruent to AC. If two angles of a triangle are congruent, then the sides opposite them are congruent. So they're going opposite, opposite. That's where they're getting that from, okay? Angle B is going to AC. I don't know why they're not keeping these in the same order. That's as good as anything. No special notes here. Focus on opposite. That's an important concept. Sorry, my pen is not... It's not that it's writing poorly. It's not lining up correctly when I write, which makes it hard to read. Corollary to the base angle theorem. So if a triangle is equilateral, it's also equiangular. So if you're given, you know, this, it implies this. This is our converse of that. If it's equiangular, it's also equilateral. This means we have a biconditional statement. 3 letters that went in here before. You might remember them. First 2 letters and last letters. I'm strategically pausing IFF, if and only if it's equilateral. A triangle is equilateral if and only if it's equiangular. That means both of these are true up here. Both of them. Okay. Also, we need to know this. You need to know this in one of the questions a little bit later. But this is something you need to know in a lot of questions. If each angle of an equiangular triangle measures what? That's 180. We got, we know the angles add up to 180 in a triangle. I've got 3 of them. I divide 60 degrees. Okay, we're going to try to make it through this. This isn't working well. Tracing these out on the diagram helps. I've already done this once, so hopefully it works this time. NJ right there. Okay. NM right there. You can see this is our third side of the triangle right there. Should be easy to do. So that makes our triangle JNM we're looking at. Find 2 congruent angles. Okay? On this one, I can go opposite it. So let's go back to the blue. That's going to be angle M. And the pink, that's going to be angle J. Those are going to be congruent there for us. Okay? And M and J. I have an M. I have a J down there. Yay. Okay. So let's look at these next ones down here. I got angle LJN. Oh, I forgot my theorem on that one though. Which theorem did I use? I had the congruent sides. I went to the congruent angles. That's going to be my base angles theorem. So that was my base angles theorem. And that's that right there. Okay, remember some of these are going to be listed more than once down here. So if you use one you need one an extra time and it's not there, one of the answers is wrong somewhere. Not necessarily the one you're on. So this time I'm looking at angles LJN. So here's LJN right there, and LNJ, that's that angle right there. So this is the angle we're really looking at there. I'm going opposite, so opposite this pink one's going to be that side. Opposite the blue one's going to be that side. We're looking at triangle LJN here. We're not looking at angle M. So I'm going to have my segments here. I got the blue pen out. Opposite this one's going to be LJ. And opposite angle J is going to be LN. Whoops. Just that, LN and LJ. There's LJ, there's LN. If you said JL or NL, that's fine too, don't forget for the segments. And that's going to be the converse of the base angle theorem that we had on that. It doesn't ask for it here, but always explain or justify your answers. If you can't explain it, you're just guessing. So always think about that. Like for number 5 here, they give me equiangular. That tells me it's going to be equilateral. If it's equilateral, that gives me these segments have to be congruent there. All of those have to be congruent. That means MN and ML are the same length. That's more formal writing for proof. And you know x has to equal 31, and we're pretty much done with that one. I'll let you finish up number 6 here. Let me see where some of these answers are. Oh, they're all up on the other page. What do you know? MN equals ML or LM. I don't see that one up there. I must have missed this one. And the 31. They're down here. Here's our ML. There's our 31. Looking in the wrong spot. I'll let you get number 6. Note this part right here we get from just after the corollaries up there. Oop, there's our answer. It's on the screen. Now it's gone. We're running low on time here. So I'm going to get in what I can here. 2 minutes left, less than that. The first step isn't always finding x or y in these problems. So, and you don't always get x before y. It's not always alphabetical order. Okay, so use what you know to get anything. If you don't know what you're supposed to do first, I don't know what you're supposed to do first. So whatever you can figure out is what you're supposed to do first, and keep going with this. So I'm seeing a bunch of stuff here. I got an equilateral triangle. I know each angle has to be 60 degrees. Okay. Well, geez, I can find this angle now because I got this right angle here. So question mark plus 60 has to add up to 90. So question mark equals 30. I can find y now because both of these are y. They're marked congruent. I've got 30 plus y equals 180 degrees. Triangle angle sum theorem. 30 plus 2y equals 180. Sorry guys, got to get better at using the pause, running out of time here. So I did the rest of the algebra, pause stuff early, and this is about to end here. So now you know what y is, you can plug it in here, and then since these two angles are equal, the sides opposite them are congruent. That makes these also congruent. So x is going to equal y minus 25. plug it in, you can get it. This is pretty much all over. So